button. Okay. So yeah, welcome everyone. Let's put that slide up again. So this is the Demystifying APIs for Researchers workshop. We're gonna understand a little bit better about what APIs are and get some practice working with them in R using the HTTR2 package. So my name's Eric. I work for the CCT Data Science Group, Communications and Cyber Technologies. We're technically an experiment station, and we are part of an experiment station. And we work with researchers in the College of Agriculture, Life and Environmental Sciences, and also extension offices and experiment stations to help researchers with data science stuff. And one of the ways we do that is with workshops, but we also do that by collaborating with people. And I'm going to talk a little bit more about that at the very end, some of these sort of options to work with us. My helper today is Christina, my boss. So she'll be monitoring the chat and stuff. Feel free to just like interrupt, unmute yourself, ask questions, very informal. Or if you don't want to do that, you can also type questions in the chat and I'll try to keep an eye on it, or Christina will let me know if I missed something. And yeah, so the way it's going to work today, I'm going to talk a little bit about what APIs are and all that. And then we are going to actually get some practice doing some like interactive live coding in R. So y'all can see my slides, yeah?
Yeah, there are a couple comments in the chat about
cool.
people's motivations for being here, if you want to.
I see that. Selena, don't need to use APIs right now, but I know that I will in the future. Yes, good job being proactive. Yeah, it's always good to at least know kind of where to go to learn stuff when you need to learn it. Kevin says nothing specific at the moment, but interested in geospatial data. Yep. Yeah, so lots of different kinds of data are available on web APIs. Yeah, in all sorts of different forms. So including geospatial data. So cool. So yeah, today we're going to understand what an API is. API, by the way, stands for Application Programming Interface. I'm not sure that makes it any more clear what it is, but that's what the acronym stands for. And we're going to get a sense of what kinds of data, what formats of data are available via APIs. And we're going to work on how to get data from APIs into R programmatically. And actually, there's like another kind of secret bullet point in here is that a huge part of getting data into R from APIs is really just like dealing with the format that the data's in. So there's actually a lot of data wrangling stuff. Like getting the data into R is like pretty quick, pretty painless for the most part. Depends on which API you're using. But there's a lot of data wrangling stuff to get into a useful format. The slides that you're seeing right now, I'll post the link in the chat in case you want to look at them. And that way you can click on links and things like that. Or if you want to just see them later, it's fine too. So what is an API? Hold on one second. Where's my, I gotta find all my windows here. So APIs provide some way that data can be accessed via the web through like URLs. And that allows all sorts of different, what we call clients, to access the data. So there's some server somewhere that has some data, some database, and the API provides like URLs, basically web access to that data. And the client, in this case, it could be like a website, a nice user-facing website that has like a nice interface with buttons you can click and a search bar and all that. And behind the scenes, that website is using the API to actually get the data and populate the views that you're seeing. Or it could be something like R or a Python script or even Excel or something like that. And it's getting that data from the API in some sort of text format. And then it's kind of up to us to get it into a useful format. So when we're looking at websites that access these APIs, they are typically nice and made for humans. And there's ways we can point and click and type in search bars and things like that. And so the example we're going to use today is this CAS Common Chemistry website. And I've kind of cherry picked this for a number of reasons. One is that the API is like relatively kind of normal and easy to use. But if we go to this website, which I'll click on right now, and I will post this, I'll paste this link in the chat as well. If you want to go on there, you see there's a search bar and we can search for the name of a chemical, and you can search for whatever you want. I'm going to search for hexanol. And we get this view. A couple of things I just want to point out, just because it'll kind of be interesting later on, is look at the URL and how it changed when we searched for that. So we see this commonchemistry.cas.org/results Q equals hexanol. So we get 2 results. And if I click on one of these, our URL changes again. We now have /detail /cas_rn equals 111-27-3 and search equals hexanol. Okay, interesting. That number, that 111-27-3 is the what's called a CAS registry number. So this is just like an identifier for this chemical. We get a nice image of the chemical. We get stuff like, the name and the molecular formula, molecular weight. We have some properties like, boiling point, melting point. And then we have all these other identifiers. So inchy key, smiles, canonical smiles. These are all just like different ways of representing chemicals in text format, representing the chemical structure. And we get a bunch of synonyms for it. So we have a bunch of stuff on here. And there's also this download button, which it's not really clear what this does, but if you click it, it downloads a file that is a .mol file. And that's another like way of representing chemical structure. You don't have to know anything about chemistry to do this workshop. This is just, this is the example I picked. So lots of other types of APIs out there. Okay, so this is nice and friendly, but what it's missing is there's not really an easy way to get the data in like a spreadsheet format, right? So if we wanted to get the data for 100 different chemical compounds, it's going to be a lot of work, right? We're going to have to search for those compounds, copy and paste stuff into Excel, probably make a bunch of mistakes in the process. It's not the way to do it, right? We want to take advantage of an API. So this is where APIs are useful. They are made for machines. They can be accessed programmatically. And APIs exist for many of these kinds of data portals. So, another example would be like GBIF. This is a global biodiversity information facility. And like if we see on here tools, we see that there's get data. We see GBIF API. So there's an API. There's KEG, which is a database of like genes and enzymes and molecules, and that is not the page that I meant to go to. But we have here an API, so KEG API with a manual. So there's lots of different sorts of these web databases that have APIs. Some of them are documented and tell you how to use them, others less well documented. But we're gonna kind of pick one that's here with commonchemistry.cas. Like I said, it's like relatively standard. So hopefully it'll be a good example to learn from. Now, getting data from an API. So every API, like I said, is a little bit different. But here, so what we saw in our URL when we searched for hexanol was this commonchemistry.cas.org/results Q equals hexanol. The API equivalent to this, and I'll show you how I figured this out later, is commonchemistry.cas.org/API/search Q equals hexanol. And if we look at this, I'm using Firefox, and so it shows up in this nicely formatted way. If you open it up in Chrome or something, and I'll paste this URL in the chat so everybody can look at it. probably looks something like this, which is like, whoa, what are we looking at? The data's in there. Like I can see stuff. Oh, 1-hexanol, right? We see that Cas registry number is in there. But there's a whole bunch of other stuff, and it's really not clear how we could use this. So this is a data format called JSON. And JSON is really ubiquitous on sort of the web. But it's hard to understand. And it's especially tricky to look at when it's not formatted in any way. And it's just like, blah, text like that. Now I mentioned again, in Firefox, it'll like format it for you. And so what we can see is that it's made of these nested key value pairs. So there's at the very top level, this thing called results and count. So count is 2, results, if we open that up, there's 2 results. The first one has a registry number, this RN, it has name, and it has image. The second one has RN, name, and image. So this is equivalent to, if we go back to that search, right? These are our 2 results from our search. And this is the data that this website here is using to like build this nice image and the name and the Cas number and all that. So image here, it starts with this SVG. Anybody encountered SVG, know what an SVG is? See some like head shakes. So SVG is a kind of, it's an image format. It stands for scalable vector graphics. So it's just kind of it's a type of image format that isn't made of pixels. It's lines that are drawn. So it is saved here in this format. This is actually HTML. And so this is what the website is using to draw that molecule, draw the image of the molecule. Yeah. Any questions so far? So
it looks like that these results don't include like any information about the actual compounds. Is that right?
yes, that is a good observation. Yeah, this here is just what shows up when you search. And so there is a different URL that we would type in to get the data that's in this page for a particular search result. And that is relatively common, that there's kind of like a 2-step process with these APIs. So we're going to get some practice with that, where we need to do step 1 to get some information so that we can do step 2 to get the actual data. So this is our URL for what we just saw. And a sort of typical API request will have the same structure. Now, they're not all going to be structured like this, and we'll look at some documentation and show you some differences, I think. But there's generally going to be some kind of base URL. So this is like where we start, right? commonchemistry.cas.org/APIs. If we want to access the API, that's our starting point, our base URL. And then we have different what are called endpoints. So we have here /search. This is the search endpoint. And then after that, we have some kind of query. And so that's this question mark Q equals hexanol, which is, that was what I typed into the search bar. And so that's the equivalent of that. So we can actually like mess around with this API manually. Here, if I wanted to change this query instead to caffeine, I could type that in, and now I have the results for caffeine, right? So we can kind of like edit these manually to get different things, and that means we can do this programmatically also. We can instead of typing in hexanol and then caffeine, and then we can programmatically do this, iterate through 100 compounds or something like that. So how do you know how to use an API? I see a question here. How is an API different from a file transfer protocol? Yeah, FTP. Do you still use an API to pull those files from the website? So an API typically just provides text. And it's usually just like this JSON text is sort of what you most commonly get. Whereas a file transfer protocol is like you're connecting to a remote machine and like downloading a file. And that file could be kind of anything. Could be a zip file or something like that. There's probably somebody more of a web developer could probably give a more technical answer to that question, I'm sure. But yeah, we're in the most, so we can also, so APIs can also go the other way. We're not going to see any examples of that today, but there are APIs where you can send them information and they do something with that and maybe send back something to you. Or if you even have like permission, you can edit the database underneath using the API. So there's different methods. The API we're using today only allows this get method, but there's other ones like post and delete and stuff like that that usually we don't have access to as just folks trying to use the data. But that's another difference with FTP, I think. So the documentation for this common chemistry, this is interesting because I think they must have changed their website since I started looking at this, because if we click here, get API, in this case, it tells us that we have to request it. We have to like fill out a form. But actually, I'm going to give you a link directly to the documentation. We don't actually need to sign up, it turns out. We can access it without signing up here. So this is the documentation for the API. And again, don't ask me, I can't remember. I think that there used to be a link to this from their homepage back when I found it a while ago. And I want everybody to take a look at that. And down here, it's a little bit hidden. There's this thing that says default, and that kind of folds out. And then each of these things folds out. Just take a moment to look at this site and poke around. And I want you to try to like figure out what are the different endpoints that we can use, and how do we, like, what kind of information do we need to query those endpoints? So just take a moment to look around. If you notice one of those things, find something, go ahead and type it in the chat. Well, hopefully everybody's had a little bit of a chance to poke around. There's a lot of information here. Let's kind of walk through it together. So I've already told you the base API, the base URL for the API, but it's there. This is how I knew it. And up at the top, it tells you there's 2 endpoints. There's actually 3, but I think these are probably the 2 that most people want to use. There's a search and there's a detail. So we saw search. Search gives us the ability to search by name, or other things. We can search by this registry number or these other representations of molecules if we have that information. Something to note here, it says the results are paginated. We're not going to deal with this, but if you were to have a search that had more than 100 results, you would have to do something to tell it, show me page 2, show me page 3 of those results. And we're not going to get into that. And then there's the detail endpoint. And this is where we get the details for a single substance, those things like the boiling point and all the data that we saw when we clicked on a particular molecule. And for that, we have to use this CAS registry number to search it. Yes, Selena, you have a question?
Yeah, so I'm trying to look at 2 different websites at the same time, the one you're going through, and then I picked one to try to understand what it is I'm looking at. And I picked familysearch.org, their API, and theirs is a lot more complicated than yours. So how do I know what you mean by an endpoint?
Yeah, so we'll use that as an example. We'll see if we can figure it out together. Let me talk through this one and then we'll go look at families. You said it was familysearch.org. If you want to, can you post a link to the documentation in the chat? And then I'll bring that up as an example because I did want to show something more complicated than this one. This is pretty simple. Yeah, thanks. So
Thank-
on this one, the common chemistry one, we have here under this default thing, this is like a typical look to what the sort of API documentation looks like. Doesn't always look like this, but oftentimes we see these kind of boxes. So we have 3 endpoints here: detail, export, and search. Actually, export is the I figured out as the download button where you get the mol file. So we'll start with search here. If I expand that, it tells me that there's these 3 possible parameters, Q. So we saw Q before. That was when we did a search for caffeine or whatever is what it showed up. I don't know what offset and size are, and it doesn't say. So unfortunately, we don't know what those do. We can click this try it out button here and actually type something in like caffeine and then hit execute. And it will give us, so this is some like command line code that we could like paste into the terminal to get this JSON text. And then there's also this URL, which is what, if we copy and paste that into the browser, we see that JSON output that looks like this. So this is showing us the response body, which is this JSON text. And then they're showing us these headers, which we're going to not really interact with too much in R. It also tells us there's a code here, code 200. So these codes, these 3-number codes are like, if you've ever mistyped a website and you get 404, that's one of these codes. Codes in the 200s generally mean everything's good. Codes in the 400s means you screwed something up, you did a typo, or website doesn't exist anymore. And the codes in the 500s generally mean like the server screwed up, like it's broken or something. So 200s are good. Yeah, 400 invalid request, 500 internal server error. This is the example here. So that is how we would use that search one. And then we can look at detail. Now detail, we can't search by name. We need to have the CAS RN. So we can actually get that from our previous thing. So under search, right, we searched for caffeine and it gave us the registry number 58-08-2. And I can copy that and then paste it in here. Oops, I got to click try it out. Paste it in here for the CAS registry number, hit execute. And now I get all the detail for caffeine. So here it tells me, name, image, but it's also got a bunch of stuff. There's these inchy key, smiles, properties, melting point, density, et cetera, et cetera, et cetera. All the synonyms for caffeine, like no-dose and, even in other languages, I think. So, yeah. Okay. So that's kind of like how we use this one. Now let's look at a more complicated API. So I am excited to see. I've never seen this before. Okay. So first of all, this is an API that requires authentication. I'm going to have some links in the slides at the very end about how to set that, like some resources that you can read through about how to set up authentication. We're not going to do that. It's not required for the CAS Common Chemistry API. But essentially here you have to like register with them and get an access token, which is just like kind of like a password. It's a string of random letters and numbers. And you'll have to provide that when you make your requests to the API in order for them to work, is my guess, just based on looking at this. So there's a way to request an access token through the API, and there's a way to authorize using that access token with the API. So already a little bit more complicated. And then let's see, you posted a link for a very specific part for person. Gives the same kinds of codes you mentioned. Yeah, so if we go into one of these are like different ways we can use this API. If we go to pick one of these, like the person change history or something. Now we see there's a path, right? So we have some base URL, which looks like it's api.familysearch.org. And then we have this path to get to it, /platform/tree/person/ something we need to provide / changes. So this works differently. It doesn't use the sort of endpoint query. It uses these things separated by slashes. And the part that we would programmatically have to manipulate is this PID. So we'd have to provide PID, which here tells us is an ID of a person whose change history is to be retrieved. So you'd have to figure out that ID somewhere and put that in. So this is a great example of a more complicated one. And we also see that there's methods for delete here, for example. So this would be like if I had, administrator privileges, or maybe this only works if it's your own account or something like that, that you could actually delete entries.
Yeah, the way it's set up right now
entries.
is anybody can delete anybody else's research. It's very annoying.
Really?
Yeah, that's why I
That
don't
seems
put stuff on here.
bad.
It's awful. They wanted collaboration and they ended up creating a mess.
Wow. That is wild. Yeah. So memories, interesting. Yeah. So you see here, the way they've done this is where they use these brackets, these curly braces. These are the parameters that you have to fill in. So a little bit different.
Right. That makes more sense. Thank you.
Yeah. And I think what we're going to do today is going to help you with that one as well, even though it is a bit more complicated. So I'm going to go now very, very quickly through the overview of how you do API requests in R. And then we're going to actually move over to RStudio and go through it more slowly. I just want to give you an overview here. So there are a number of different R packages that you can use for this. We're going to be using the HTTR2 package today. I find it the most friendly, user-friendly, and kind of easy to use and helpful in terms of error messages that it gives and all that. So why would you do this? Why are we doing this? Well, we can now produce, if we do this as code instead of typing in the URL or whatever, we can get reproducible queries so that we can kind of run the query again in the future and get the same results back, or maybe updated results if the database is updated. We can also, and this is really the big one, we can iterate over many queries. So once we figure out how to get that one piece of information we need for one molecule, let's say, the SMILES, that code for the molecular structure, we can get it for 100 molecules with relatively little extra work. And we can create reusable functions, perhaps, that we could share with other people. And maybe even you want to create an R package or something for an API. You can do that. So we're going to load our package HTTR2 here. And the first step is to create the request, build the request. And we do that in steps here. So first we set the base URL with this request function. And then this is the pipe, which I'll talk about what that is in a second for if anybody's unfamiliar. But basically we take that, and then the next step, we append that path with search to get our search endpoint. And then we have this URL query function where we say Q equals hexanol or caffeine or whatever. And when we then run this rec search thing that we've created, this object is an HTTR2 request object. It tells us here the method, which is get, that's the default. And it's going to tell us the URL that it's going to try to get data from. You notice that all these functions both start with rec. So these are functions that are related to requests, start with rec. Then we want to perform the request with rec_perform. And we get this response back, tells us status 200, okay, tells us the content type is JSON, and tells us how big it is. Then we have that response, and we can get the data out of it using, there's a number of functions that start with resp. So response body JSON here pulls the data out that is in JSON format, and it puts it into a list format in R, which maybe is a little bit more familiar if you're an R user. You might have encountered lists before. And we're going to spend a a good bit of time dealing with lists because they're difficult to deal with. So that's the overview. So I am going to switch over to RStudio now. And I'm going to close some things so I have all my windows in the right place. Yes. How's the size there? Everybody see that okay?
That's good for me.
Yes.
Cool. So hopefully you all can follow along with this. If you can open up RStudio, open up a blank script and follow along, that would be great. And we're going to start with library HTTR2. Now, if we run this line and you get some kind of error, it's probably because you haven't installed it. And so you can install that with install.packages in quotation marks HTTR2. I'm not going to run this because I already have it installed, but if you hit enter there, run that, you'll get that installed, and it should install pretty darn quickly. Yeah, so the first thing we got to do is, oh, and we're also going to load library tidyverse. This is something that we're going to use later on to do some of the data wrangling stuff after we get our data from the API. And this will print out, if you have it installed, will show you that it's actually loading a bunch of packages. We're going to be making use of a few of these, but in particular, the per package is really useful for working with lists. So that's one that we definitely want to be using today. Okay, so first we got to build our query. And that base URL was let me copy and paste that again. That's our base URL, right? This in quotation marks. And so we start our request with the request function. So request, that's our request. And if I just run this, so I'm going to hit on my keyboard Command Enter to run that line. And it just tells us what that URL is. It kind of spits that out, right? So we want to save this as an object. I'm going to call it rec_search because we're going to be doing the search API here. And then the next thing I'm going to type is a pipe. There's two different pipes. There's a keyboard shortcut. So let me take a little bit of an aside to explain what the pipe is for those of you that don't know. So on my keyboard is Command-Shift-M is the keyboard shortcut to type the pipe. Now, if you do that, it might look like that, or it might look like that. These are essentially equivalent. This one here is built into R, starting in R version like 4.2 or something. So maybe if you have an older version of R, this one doesn't work. And this one here is a part of the tidyverse. They both do the same thing. They put whatever's on the left side into the first slot of the function that's on the right. So we can do something like mean 1, 2, 3, na.rm equals true. I guess I'll add an NA here because that makes sense. So we have this vector of numbers, and then we have a function, right? Oops, I gotta delete these because they're doing weird things. So if I run that, yeah, it tells me 2 is the mean. Now we can actually do the exact equivalent of that with the pipe by starting with our vector of numbers. And we can do a pipe into mean here. And this does exactly the same thing. So it takes whatever's on the left and puts it in the first slot of whatever's on the right. And so all of these functions that start with rec underscore, the first argument is a request. And so since we're using the pipe, we can just leave that blank and we can just put in what we want. So the next thing, does that sound good to everybody? Everybody kind of understand what the pipe is doing here? It's a way of chaining things together. Doesn't work with every function, but cool. please let me know if you have questions. So we want to now add that search endpoint. So we're going to do rec underscore URL path append to add another slash thing to it. So we already have slash API and we want to add search. So if we run that, I'm going to comment these out and move them up to the top here, just so they're out of my way. So now if we look at rec search and we run that, we see now we've got the search on it. And then we're going to add the query, rec URL query. And the way that we do the query is we got to look at our documentation, right? So we're going to start with a search API here. And we look at what the name of the parameter is. It's Q here. So we're going to say Q equals caffeine. And now we see that we've got our URL. So why would we do this like this complicated way instead of just putting it all in here? Like we could type slash search question mark Q equals caffeine. We do it this way because if what we'll get to in the future is we want to iterate over a bunch of compounds. So all this is going to be the same. And the only thing that needs to change is what's right here, right? Caffeine, hexanol, whatever, geosmin, we're going to change that to be a bunch of different chemicals. So doing it in steps like this helps us program it later. So now we've got our request, and now we want to actually perform the request. And we do that with rec perform. And that's our request there. And let's save this as resp underscore search, our response for our search thing. And I'll run that. And it might take a moment because, it's getting data from the internet. And if I type resp search, I get some information back. It shows me it worked, shows me it's JSON. So I'll give everybody who's following along a moment to get caught up to this. So let me know on Zoom with like a thumbs up or a green check mark if you've been able to actually do this request. And if you're stuck or you need help, give me a red X or something like that, or just speak up.
I'm getting an error that says they can't find the function request URL path append. And I did install.
Did you also load it? So you install it. That's something you do once, and then you need to run this library HTTR2.
Yes, and tidyverse.
Did you type rec or request? Because it's actually rec after the first one.
REQ.
Yeah.
Underscore
REQ.
URL.
Yep. Underscore URL underscore path underscore append.
Yeah, exactly the same.
Okay. I'm gonna stop sharing. Let's take a look. And would you mind sharing your screen?
Sure.
If I allow it? Yes. Now you should be able to. Be easier to just take a look.
All right. Do you see it?
Yes.
Okay.
I do. Okay. So could not find effect function path append. So can we just go back up to the very top and just like on line 2 there, and we'll just run all of those in sequence, just like you can either click the run button or command enter. Just make sure if we start from the top. Okay. So there's an error there with loading HTTR2.
I see. I need to update RStudio. Okay.
No,
yeah. Well, because it's
so rlang is another R package. What I would try doing is just restarting the R session. So if you go up to the session menu in RStudio, like up at the menu bar, And there's an option that says restart R, and try that, and then kind of like start at the top again and see if that works.
Okay. I don't think I've ever started R that way. Where is the menu bar?
Session, there should be a menu item called session. I can't see your menu bar, sorry, but just the way that it's shared. But up there somewhere, it goes file, edit, code, view, plots, and then session. And then, yeah, there's restart R down in the middle there.
Okay, got it.
And so now you could maybe try library HTTR2 again and see if it gives you that same problem. Okay, so it worked that time. Yep. When in doubt, restart, try again. Cool.
Thank
So
you.
yeah, that works. Okay, let me go back to my screen here. So yeah, so once we build our request, we can do rec perform to search it. I wrote it this way, but I could have also written it. It's also totally equivalent to write it like this with using the pipe, right? That works too.
Can I ask a question about this, what the rec perform is doing? I mean, I guess it's running this get and then your request, the search that we typed out.
Yeah. So
But
it's actually going to the web and it's actually, you know, doing this URL kind of thing, basically. Like,
okay. But it's not you still need this third step before you can like get it into R. So it's like,
so it's there, it's in this response object. It tells us here it's in memory.
okay.
And I think like if we were to look at the structure here in the environment tab of this search, we see that it's got a bunch of stuff in it, including, you know, body here, which is things, it's like raw hexadecimal 7B2263, right? Like we don't want that. We want it in JSON format. So it just doesn't print all this stuff out for us because we don't need to see it all. And there's like a nice convenience function for us to actually get it out in a usable format.
Okay, so the search has already been performed here. The next step is just to like make it look tidy for us in R.
Yeah. So if I type resp underscore, you see that there's actually a bunch of different functions here, and these would match with whatever the content type is. So like, and there's actually one here, resp, you know, check content type. So in this case, we have JSON. So we want to choose the matching one here, but it might tell you under content type, it might tell you HTML or something like that. Or, you know, text, string. Usually, I think the most common is JSON. And so if we run resp body JSON now, we get a list. This is a list in R. And let's save this now. I'm going to save this. I'm going to call it caffeine search. And I just like putting these on different lines to make it look nice. So yeah. So there's caffeine search. Caffeine search is a list. We can see it over here in the environment tab, list of 2. We can also do capital V view caffeine underscore search, and that will open it up in like a new tab here where we can explore it. And we can see the same kind of stuff we saw before, where we've got a list of 2. One of those items is an integer. One of them is another list. Inside of that list, there's another list. Inside of that list, we've got the registry number, the name, and the image. So this is typical. It's a very nested list. It is not in a useful format for us. All we really want is these 3 things, right? Or even just this one thing would be great, right? The registry number. So how do we get stuff out of there? That is the challenge. So in this view, we can actually see there's this little icon. When I hover over different rows, I get this little icon. So I can say like, you know, this is the thing we want, just this inside list here. And if I click on this, it actually puts some code in the console here that if I run it, gives me, you know, just that inside nestedness here. So I'm going to copy that and put that in here and call this just caffeine. So what this is saying is take this caffeine search list, double braces we use for lists. So this is saying take the element of that list called results. And back over here, we see there's an element called results. And then inside of that, take the first element. So we can index by the name or the number. Yeah. So yeah, it's a pretty neat little feature of this this editor is you can you can, or this viewer, you can click on stuff to get the code to extract it. So now we've got like just the caffeine bit, and it is much more manageable now because it's flat, right? There's just these three elements, and in fact, because it's flat, we could turn it into a data frame like so. And now we've got a data frame with 3 columns, RN, name, and image. I'm actually going to use a tibble. A tibble is like a data frame. It is a data frame, actually. It just prints a little bit nicer, and it does less for you. Like, it doesn't try to convert column names and stuff in unexpected ways. So tibbles are part of this tidyverse thing that we loaded. So that's our caffeine data. I actually don't need to save that as something yet. We'll just have this here. So this is like, great. This is a 1-row data set. This is a format that we're probably more used to working with as data frames, right? Now, let's get detail, right? We want to get some detail about caffeine. So we're going to use that detail endpoint. So we make another request. We're going to call it rec detail. What's the first thing that for building a request? What's the first thing we need to do? Can type it in the chat or speak up. What is the first piece? Yeah, we need our base URL. So we're going to use request, and we're gonna get our base URL. Now, something we could do, like for convenience, is we could make something like that's called base URL and call it this, or save this as something called base URL. That way we don't have to type that every time. We could just say base URL. So I have to run that for it to work. I have to remember to do that. So we could do this down here, base URL, cool. And then we need our endpoint. So we're gonna rec URL path append detail. And we see that we got our /API/detail. Now, what if I hadn't used the append here? The reason I'm using append, if I do this, it actually replaces this /API with /detail. We don't want to do that. We want to append. So got to remember to do that. Those are easy to mix up. And then we add our query. Now, what's the query going to be? This is where we go back over to our API now. Documentation for detail. It's called cas_rn. So cas_rn. And we could, in here, we could like go to our caffeine data frame here. We could look at this number, we could copy it and paste it in, but we're programming here, right? So we're gonna do this programmatically, and we're gonna look at caffeine, $ to get the different elements of it, RN, right? So if we were to run this just on its own, if I copy and paste this here into the console, it gives us the registry number, but we can pass it to this rec detail in this way. So now we have our request. There we go. That's our request built. What's next? We've got to perform the request, right? So I'm just using the same kind of convention here, I guess. Call it resp detail, and I'm going to say rec perform rec detail. So we'll perform our request. Nice. And if we look at that, it tells us it worked. It's JSON. It's in memory. Sweet. And we can get it out with resp body JSON again. Oops. Body JSON. Heavily making use of autocomplete here. If you know you're working with a response, you just type resp underscore and you see all the things you can do with that, which is a lot. And so we're going to do resp body JSON to get our list. So this is our, let's see, what do I want to call this? What do I want to call this? Caffeine detail. So caffeine detail is this list. We can use view on it. Again, open it up in a tab here. We can see that this is a list of 15 elements. Many of them are just a single length one character, right? So the registry number, the name, the image, Inchi key, smiles, blah, 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 molecular mass. But then we've also got a list that has 2 lists in it. And those lists each have length 1. We've got, a list here of 42 synonyms. Great. It's complicated. It's kind of a mess. It's all these nested lists. So if we were to try to make this into a data frame with as Tibble, caffeine detail, yeah, it's going to tell us it can't do that. Now, this is a great example of why I like as underscore Tibble, because if we do as dot data dot frame detail, what's going to happen? Think about it, predict it in your head. What the heck? So it works. But how did it do that? How did it make those things into a data frame, right? It made like a bazillion columns. So we have synonyms.guaranine, synonyms.dot methylbromine. That's not really what we want, right? Like, I mean, this is not gonna, we're not gonna be able to combine this data set with the data sets for other chemicals because they're not all gonna have the same columns. So that's not really what we want. I'm gonna just like comment this out so that we don't do that. So we have this list, but we want to get just some pieces out of this list so that we can make a data frame. So here's a little bit of an introduction to like working with lists with the per package, which we loaded with tidyverse. One of the functions in there is called pluck. Oops, not all caps, pluck. We can get the help file for it. And we see that it takes a vector or a list or something else, and we can tell it what we want to pluck out of there by in a few different ways. It could be numbers, it could be names, things like that. So this is actually, we kind of did this before. We did something like this. We could do caffeine name, caffeine detail name, and it pulls out just caffeine. Well, the equivalent of that with this pluck is caffeine underscore detail pluck. And that's the same thing. Why would we do this one over this one? It's a little bit easier maybe to chain things together, and also we're gonna do something that we can't do with square brackets with a slightly different function in a second. That's like this. We can also do by position. So we could say pluck 1. And that takes the first element of that list. And we can also use pluck to kind of nest things together or drill down into a list rather. So I could say take experimental, let's see, what is it called? Experimental properties. And then inside of that, take the first element, and then inside of that first element, take property. And we get this 238C. So this is saying basically, go to this thing called experimental properties, take the first element, and then take the one called property. So the equivalent with brackets looks like that. So that's just a different way of getting into lists like that. Now, what if we want to do something like we want to turn all these ones that are 1 character long or one length 1, turn those into a data frame? Like that'll work. That should be easy. It'll be a 1-row data frame. So we could use pluck to do this, to pluck out like all of these columns by name, but we can also do it programmatically with a slightly different function, which is keep. So keep takes a list as the first argument, but then the second argument is a predicate function, a function that returns either true or false. And it could be the name of a function, like is.character. So we could say caffeine detail keep is.character, and it would keep all of the elements that are characters, which actually does pretty good job in this case, because they all, I think all of these length 1 things happen to be characters. We could also do something more complicated if we wanted to with an anonymous function. So I'll just show you that. Caffeine detail keep, and then we could provide a function like this, and we could say length of x equals 1. So what this is saying is basically for every element of caffeine detail, this list, check whether that element x has a length that is equal to 1. And if so, keep it. And then we can turn that into a tibble. So I'll just run this on its own. We see this gives us an additional column. This has multi-file true. This isn't character, this was logical. So maybe we want to keep that too. And then this we can turn into a data frame. Ta-da! Cool. So we have our details now in a data frame. And we'll save this here as caffeine basics, something like that. Cool. So that's our data frame. How's everybody doing? We have, the next step is really exciting, where we search not just for, we get data not just for caffeine, but we get it for multiple compounds. But I want to check and see, do folks want to take a quick break?
We do have a raised hand.
Oh, we do. Sorry, I
And
missed
there was
that.
a thumbs up.
Let's do
There was
that
a thumbs
first.
up a minute ago too, so that was good. But yeah.
Okay, let's hear from Erica. You have a question?
Yeah, this last part was really helpful. I have never used pluck, or I've used keep, but very little. So I was wondering can you describe what this function x length x equals 1 does? Like where is it pulling the data from within the tables?
Yeah, I'll talk a little bit more about anonymous functions because they're going to be really important for us. So a different way we could do this, right, is we could write our own function, and we could call it like keep len1, for example. And the way that we would create that function is by making a function called function. And then we could call this argument whatever we want. I called it x before, but I could call it like bar. Doesn't matter. And then what this function does is it does length var equals 1. Now we've created a function. We see it here in the environment. This is how you would make your own function in R. So we could say keep len _1, 12 and 13. It's gonna, oops, I spelled length wrong. There we go. Spell that correctly. It's going to tell us false. The length of this is not 1, it's 2. But if I typed in, the letter A, it's going to say true. And we could actually then, now that we've created that function, we could, instead of doing that the way we did, we could instead here just type in the name of the function we created, keep len1. That also works. This is quite a lot to do something kind of simple. And so this is just a little bit of a shorthand way of doing it. is instead of giving that function a name, keep underscore len underscore one, it's anonymous. And that's what we mean, but that's what an anonymous function is. It means we're not naming it, we're not saving it as something because it's not going to be reused. We're just using it in this one situation. Basically, what it's doing here is it's going through every element of caffeine detail and using our function. It's kind of like iterating through it like a for loop. So it's going, okay, caffeine detail, the first one, keep len one. Oops, I gotta put parentheses there. True, and then it's going to the second one and true. Okay, cool. I'll keep that one, all the way to the, the end. And it's going, oh, that one's true. Keep it. So we're just doing this in a shorthand way with this anonymous function. And actually, there's even a shorter way to do it that was introduced fairly recently in like our version 4.2 or something. We can just use a backslash there instead. So we can say \x, that's our anonymous function. And yeah, does that help understand?
Yeah, I hadn't seen that before, so that's cool that I didn't know you could do that. So
Yeah, we're gonna use it a lot in the per package. You'll encounter these anonymous functions quite a bit because we're basically saying iterate through a list and do this to every element of it. And anonymous functions are really useful for that.
Can I ask you, Eric, this is a little off topic, but I was using this very thing earlier, these anonymous functions, and it seems like when I search for help on this sort of thing on the internet, there's like different iterations of, or like I can't tell if it's like different points in time or like different syntaxes from different packages or something, but sometimes you can just use like a dot, like a period, like represent like the X or something, or some people
so there is a way, an old way that is no longer recommended in the that is a tidyverse specific thing. And I actually don't know if it works with keep, but you'll sometimes see this this squiggle.
Yeah, and then dot,
and then a dot.
Period. Yeah, exactly.
I think this might not work with keep. Oh, maybe it does. Yeah, this is something. Whoops. Where'd I go?
Well,
This is you will see this sometimes, this squiggle, and then a dot.
yeah.
This is a tidyverse specific thing. And so it only works in tidyverse functions. And so the tidyverse themselves are, the developers of these tidyverse packages no longer recommend doing that or teaching that because it only applies in the tidyverse, where we can use these sorts of anonymous functions anywhere in like base R functions like lapply or something like that.
So
which,
it was
takes a function as an argument. You can use for this fun argument, you can use this \x thing in that, but you could not use the tilde and the dot thing. It would not work in lapply. So
okay, so that's just sometimes when you go like Google for help, there's like different vintages of help, Stack Overflow.
Yeah, it's a good thing to bring up because you might see something that looks like this. Maybe even it has some curly braces around it. And then you would see like, length of period equals 1. Like that is a way that you'll see these written sometimes for tidyverse functions. But it's it's
gotcha. Yeah, I didn't want to confuse folks here. It's just I've had this question because
it's good to know. You might see it.
Yeah,
you might see it differently. And these anonymous functions, by the way, are I think calling them anonymous functions is an R thing. And I think in other programming languages that have the same kind of thing, they're sometimes called lambda functions. I don't know why. I feel like anonymous function makes a lot more sense. But if you know Python or something, I think they call them lambda functions in Python. So yeah, Erica says the shorthand is nice, but it'd be hard to understand someone's code if you were new to R. Yeah, it's not really clear what /\x is. So writing out function is a lot more clear because then at least it has something to do with functions. So I agree with that. Okay, How are we doing? Does anybody want to take like a 5 minute break to grab a snack or something before we look at like iterating over multiple compounds? Let's stop sharing so I can see. Let's just do it. Let's just take like a 4 minute break so we can all get some water and take a snack or whatever stretch. So we'll come back at I guess it's 12:12. Sound good? All right. Okay. I am back. Where the heck did my little videos go? Can't see anybody. Okay. Let's see. We had a question in the chat about rec detail not working, getting bad request. Did this help seeing this? I'm my guess is maybe this is not the right thing, or maybe this doesn't exist yet. You don't have the caffeine request.
Also typos in the URL.
Typos in the URL could do it.
Possibly.
I sometimes like it doesn't work for me because I forget that I actually like I wrote this, but sometimes I'll forget that I need to actually run that line of code for it to work. so that it actually saves that base URL here. What is the if you just before you do rec perform, what when you run rec detail, what do you see here for the get? Can you put that in the chat maybe, and then can figure out if there's a problem there. Okay, that person might be not at there. Oh, there we go. Never mind. Please move on. Okay. Hopefully that worked out. It's okay if you have issues. It's always good to like work through those together. But yeah, common mistakes that I come up with is I like forget that this has to be whatever the API wants it to be, or that like like I said, like I've created an object called base URL or written the code to create an object called base URL, but I forget to run it or something like that. And I usually end up with problems, or I just do typos or something. Okay, so we have got now this caffeine basics data frame, but it would be nice if we could have a data frame with 100 compounds or whatever, right? That's ideal. We want to search for a bunch of things. So I'm going to search for several compounds, and I will paste this into the chat here. I'll just paste exactly what I pasted into my R script here. So we've got here caffeine, vanillin, which is vanilla, the scent of vanilla, and bergamatine, which is bergamot, which is an Earl Grey. So I was like, oh, it's like a vanilla Earl Grey. It sounds pretty good. All right. So we're going to search for some properties related to these. So I've created now this vector. I have to remember to run this, not just copy and paste it in, called chemical names. And we're going to iterate over that. So when we search for all of these, all of the queries are going to start the same way. So I'm going to make a new request and call it like rec search base. It's going to have that base URL, and the endpoint is going to be the same for all of them. Search. So that's our base search here. It just goes to the search endpoint. We don't have a query on it yet. And what we want to do is we want to create queries for all three of these. And there's a bunch of different ways we could do this, but we're going to stick with the purrr package and use one of the sort of workhorse functions in the purrr package, which is map. And map, oops, not mapply, map. Map applies a function to each element of a vector. And a list is a vector. It's just a weird one. So I typically use it with lists, not with sort of regular, they're called like atomic vectors. We're going to use map. So the way map works, first argument, oh, why is this highlighted in such a weird way? That's driving me nuts. I'm going to close this and open it up again, I think, because it is driving me that crazy here. Open recent files. See if that fixed it. Yes. Okay, great. So the way the map works is the first thing is our vector or list that we put in. So chemical names. And the second thing is a function. So this is, again, a place where we can use an anonymous function. And I will do this. I will type out function because I know there's some strong opinions about it. And we can actually use these curly braces to make it a little bit more readable. So the function will like do everything inside the curly braces and only give us the last thing that happens in it. And so we're going to take our rec search base, and we're going to append to it rec URL query. And instead of like hard coding this as caffeine, vanillin, or bergamatine, we're going to say X here. So this is going to go through every element of chemical names. And for each element X, it's going to start with the rec search base and append a query that is that element of X. So if I run this, it gives us not one request, but it gives us a list of 3 requests. So one for caffeine, one for vanillin, one for bergamotine. So you can imagine you could have a spreadsheet of 100 chemical names, and you would get a list of 100 API requests. So let's save this. And I'm going to call it rec list because it is a list of requests. Request list. Great. And now we can use map again to do stuff on those requests. So we're going to map rec list, and we want to perform the request. Now, because rec perform doesn't require any arguments or anything fancy, we actually don't even have to use an anonymous function. Again, like we saw with keep, we could just put the name of the function in there. So all we have to do here is rec perform. We just have to make sure not to have parentheses after it. We just need the like naked definition of the function. And let's save this into something called resp list. And we get our responses back. And so now resp list, I'm going to say view that. We have a list of responses. So 3 responses, 1 for each of our chemicals. And there are these, each one is like a response, is one of these response objects, these HTTR2 response objects. So resp list, print that out again. Yeah, we get 3 of these responses. Cool. Now we could get the data from all of those by saying map resp list resp body JSON. This is going to give us like quite a nightmare of nesting, though, right? So if we put that into view, we now have a list of 3 lists. Each of those is a list of an integer and a list, which has a list, which has 3 elements in it. I think, so we could like wrangle this, but I think actually instead of just using this plain resp body JSON in here, I think it's nicer to do a bit of the wrangling inside of this map. So we do it for every element instead of getting a big nested list at the end. And if that doesn't quite make sense, hopefully it will as we go through this. What I like to do is start with just one of the elements of resp list and figure out how to do it with that. So if we just had resp underscore list, if we just had caffeine, right? And we've done this, right? We've figured out how to do this already. If we just had that, we would go resp body JSON to get it into a list format. And then we just need that results bit, right? We just need to drill down in the list. And so we've done that before. So we can do that with pluck results 1, for example. And that gives us just the results for caffeine. And we could turn that into a data frame. So we have this little like these steps here. We take a response, we turn it, we get the JSON out of it as a list. We pluck out just the results and the first element of those results. So this is just taking the first search result, which, you know, maybe you'd be interested in keeping them all or not just taking the first. But in our case, there's only one result for all of these. So we're just taking the first one, turning it into a data frame. We want to do this with every element. So we could, you know, if we change this to a 2, now we have vanillin and so on. But we can do this in map. So instead of just map resp body JSON, instead, we're going to make an anonymous function again. We'll call it like that. And we're basically going to copy and paste this in here. And instead of resp list 2, X. So every element of resp list, we're going to get the JSON, turn it into a list, take out the results, the first element, turn it into a tibble. If we run this, we now get a list of data frames. Sweet. And we can add one more step to this to combine those. So we'll save this now. Let's call it df_list because it's a list of data frames. And we can combine those all with a function called list rbind. And now we have one data frame with all three or 100 of our results. And one of the columns is this rn, which we're going to need if we want to get details, right? So we'll save this as search results. And we've got all our search results. I am going to leave it up to you as an exercise if you want to repeat this process and go through. And I'm going to share these notes with you. I'm going to leave it up to you as an exercise if you want to go through and then take these RN numbers and plug them in to another request to the detail endpoint. So that would be the next step. Take search results $RN and plug into requests to the detail. And that would be a really good way to practice this data wrangling stuff, wrangling lists, which is hard. And it takes practice, and it takes a little bit of an understanding of anonymous functions and how this map thing works. And it takes a while to click, and that's okay. So I have a few more slides to show you, but I want to pause here and just make sure, are there any questions about kind of what we just did in getting these three results into a single data frame?
Is the list underscore rbind just like a way of doing do.call, but with the arguments flipped?
I'm not sure.
Do.call rbind?
Yeah, maybe. I'm not really familiar with doing it that way. I know list underscore rbind, and I know what is the other one? Bind underscore rows. Those do the same thing. So there's a bind underscore rows, df list also does that. Bind underscore rows is from the dplyr package. List underscore rbind is in per. I'm not exactly sure off the top of my head what the difference is and how they behave. I think they do behave differently in certain circumstances. I assume by the name list rbind is that it always only takes a list, and that maybe bind rows takes other things. But yeah, there's different ways to do that.
Yeah, the
oh yeah, here
base
we
way
go. Oh yeah,
before all
do.call
this-
rbind dfs. Yeah.
Yeah, it's just flipped because you can't pipe into do.call because the argument is function and then list, and you need it to be list and then function for piping to work. I wonder if that's the only like major difference there.
Yeah.
So fascinating.
Yeah, so
There's many more
bind
options.
rows, you can do like a data frame and then another data frame. It doesn't only take a list, but it does work with lists. So both are useful. Yeah. Very useful for map because you're mapping over lists. Basically, the pattern is like you get your JSON data. It's a messy list. You take the pieces out of it that you want, and then maybe turn them into a data frame or something like that. And then at the end, you combine them all into one data frame. There's also functions like map underscore character or underscore DBL for numeric. So if you wanted to get like a numeric vector out of it instead of a list, if you had like numeric data, like we were just picking out, just one thing, like the molecular weight, we could get a vector of molecular weights, all kinds of stuff you can do. But yeah, this is, I feel like, a pretty general pattern for how I work with APIs. So let me switch back to my slides here. and share them. So hopefully that was helpful for everyone. I know this was a very sort of basic API and not like a super complicated one. I picked this one for a couple reasons. One is, yeah, it was pretty simple. Two is there's not already an R package that does it. I'm going to come back to that slide in a second. So don't reinvent the wheel. This is really useful stuff, but before you start writing HTTR2 code to access your API, do some due diligence and look and see if there's an R package that already does it. Because as you could see from this demo, it's not as simple as just writing the request. There's always data wrangling to do. And for many APIs, there is an existing R package that will do that data wrangling for you and make things a lot easier. So an R package or a Python library or something like that. ROpenSci is a great place to start. It's an organization that has a number of R packages, and they have data access category of package that I'll put this link in the chat here too, in case anybody wants to browse it. But there are over 100 packages. So GBIF was one example that I talked about. We wouldn't want to write HTTR2 code and deal with the GBIF API because there's already an R package that does that for you. And this particular example was inspired by, there's an R package called Webcam that common chemistry, yeah. So there's a package called Webcam in ROpenSci that accesses a bunch of different chemical APIs, but common chemistry is not one of them. And so if you are inspired by this demo and you would like to turn these API calls into functions and make a contribution to the Webcam cap package, I encourage you to do that, and we'd be happy to help you guide you through that process if it's something you're interested in learning how to do. But yeah, don't reinvent the wheel. I also want to point out a few other really important functions.
Sorry,
oh, go ahead.
Before you talk about that, I do also want to point out just like a terminology thing that oftentimes those R packages or Python libraries or whatever are called API wrappers.
Yes.
So if you see that term, that's what that indicates.
And there's also, there's building on that. I love sometimes people will say if there's an API wrapper that really doesn't do very much other than get the data, like it doesn't do any of the data wrangling stuff, turning into a data frame that we did. Sometimes people will say it's a thin wrapper. I like that imagery. It's a thin wrapper, it's doing a little bit, but it's not doing very much. And so they do sort of vary in that ability. In the HTTR2 package, I want to point out a few other important functions that you will maybe use. So many APIs have a rate limit where they won't let you make tons and tons of requests in a row. The Common Chemistry API either doesn't have one or they have not told us what it is, and we haven't run into it. But many APIs will tell you there's a rate limit. Many APIs will have a rate limit and they won't tell you there is, and you'll just get an error. And so rec_throttle is the function that you would use to modify your request to add a rate limit so that it will only, when you're doing things like iterating and doing 100 requests, it will only, it will pause between them basically. So you can say only do, 20 requests a minute or something like that. And it'll take care of that for you. Rec retry will modify your request so that if there's an error, it will automatically retry. And you can tell it, how many times you want it to retry and how long you want it to wait between retries. And so that's, sometimes APIs like are down or your internet connection is not good and you just want it to try again. And then in the beginning, we talked about authorization, or when we were looking at that example, that genealogy API. Many APIs do require that you authorize yourself in some way, that you sign up. You get a token. They want to know who you are and how you're using it. And that stuff can get tricky. But we have this rec_OAuth_auth_code function, the help file for that. And this article here is very useful. There's a nice article on the HTTR2 website all about authorization. And if you do have to deal with an API that requires a token or something like that, I would suggest reading through this and going through some of these examples is a way to kind of get started. So yeah, so that was the workshop basically. On a closing note, I do want to mention that we have drop-in hours every Tuesday, 9 a.m. virtual, and you guys are all welcome to join to ask questions about APIs or other stuff related to data science. You can also email us, cct-datascience@arizona.edu, if you have questions. I'm available to meet with you too. I have appointments that you can book on our website. And I also want to tell you, mention this data science incubator program. So for example, if accessing an API is something you're interested in for a project, that's something we can help you out with. The data science incubators are pre-funded, I'll say, for folks who are in the ALVSCI acronym, which includes the College of Agriculture, Life and Environmental Sciences. And basically you get 80 hours of our time to do some kind of data science project that we hand back over to you at the end. And you can see on our website the sort of variety of stuff we've done in the past, including interactive data visualizations, R packages, dashboards, analysis project, sort of code makeovers, databases, all kinds of things. And so if that's something you're interested in, just shoot us an email and we'll set up a time to talk about details more.
And I just want to point out about the incubator that's open to anybody who's doing anything research based. So we work with grad students, faculty, postdocs, staff. So yeah, it's not limited.
Yep. So thank you all for coming. I'm happy to stick around if there's any questions at the end. I will send you all a follow-up email with a link to the recording of this, a link to the slides, a link to the notes that I was working off of. Like I had my own notes that I was retyping in the R script there. And I will send all that stuff to you guys later this week or beginning of next week. And yeah, please reach out if you have any questions, or yeah, stick around if you have them. So thanks for coming.